Hello guys, this is Prime Concept. In this video, we want to learn how we can derive the formula for length, which we know as length formula, thin length formula. So we want to look at how the formula is derived, right? So that we don't confuse it for mirror formula whenever we're solving problems. Now, following our Cartesian sign convention, you would understand that our mirror formula and less formula look similar, but they are not exactly the same. And that is why I'm taking my time to derive it, to prove that, so that you don't mix these formulas whenever you're solving problems. Now, in the process of deriving this, I'll be introducing and using the sign conventions I mentioned and explained in my previous video. So if you have not watched the video on sign convention for convex and concave lenses, do well to watch that, then come back and follow on the derivation. So we're going to use one of the ray diagrams to derive this. So say I have my convex lens. This is my convex lens. And this is my focal point F. This is my focal point F. So I place my object somewhere around here. Right? So following my rules for image formation. So if I have this parallel ray, when it hits my lens, it will come through the focal point, right? So if I go through the optical center, I would have this. When I go through my optical center, I would have this to go unrefracted. So this point where they intersect is where our image would be formed, right? So I'm going to simply label this diagram so we can use it. So I'll call this, remember this is my object, so I'll call the height AB, call the height of my image A prime, since it is the image for this, so A prime, B prime, right? I'm going to label this also and call this height, call it P, call this center, I'm going to call it C, optical center. Now notice that this point is our point F, right? Now, if you look at this very carefully, you notice we have similar triangles here. For example, this triangle is similar to this since they have same angle, vertically opposite angles. So these two triangles are similar. What are the triangles? Triangle A prime, B prime, F is similar to triangle PCF, right? Again, you would notice that triangle A prime, B prime, C is similar to triangle ABC, right? So we can use the idea of similar triangles, the ratio of their sides, to derive this. So let's start comparing triangle ABC, which is equivalent or similar to triangle A prime, B prime, C, right? So if we compare both, we would have that the ratio of their heights, AB, to the height there, A prime, B prime, is equivalent or equal to the ratio of their length, which is AC to the length A prime C. So I'll call this equation 1. Now if I consider triangle A prime, B prime, F, which is equivalent to triangle PCF. PCF is equivalent to A prime, B prime, F, right? So if we do that, we would also arrive at a relation. Let me do it here. We would also arrive at a relation comparing their sides. So we have that PC ratio A prime, B prime is equivalent, is equal to CF ratio what? A prime F, right? Now, if you watch carefully, what is PC? PC is this height, which is same as this height AB. So we can say that PC is actually equal to AB. So if that is true, because this height you can see is the same, if that is true, I can replace PC. So I would have AB ratio A prime B prime equal to what? CF ratio A prime F. I'll call this equation 2. So you notice we can equate 1 and 2. Why? Because this is AB, A prime, B prime. This AB, A prime, B prime. They are equal. So we can equate 1 and 2 so that when you equate 1 and 2, equate 1 and 2, when you do that, you'll be left with AC ratio what now? A prime C equal to CF ratio A prime F. So I'll call this equation 3. Now, what are these parameters? AC, A prime C, and these things? We can get them from this diagram. So we can say that AC, A to C, is actually the object distance. So length AC is our object distance. And using our sign convention, our object is located on the negative, on the left-hand side, the negative side. So it means that AC, which is the object distance, is going to be negative U, right? Since it's on the negative side. Now, what is actually A prime C? A prime C is the distance from your image to your lens. So that is image distance. And your image is located on the positive side, which is on the right-hand side. So it means A prime C is going to be positive V, right? Then what is our CF? CF, this is the center. C to F is our focal length. So CF is our focal length, which is also on the positive side. That is why F is positive, right? Then finally, we have A prime F. Now, if you check, this is A prime F, this small distance, which is actually going to be the total distance A prime C minus CF. So this is actually A prime C minus CF. So that my A prime F becomes A prime C is V, CF is F. So this is what I have. So I'm going to substitute these parameters into equation 3. So if I do that, I'm going to replace AC with what now? With negative U all over A prime C prime, which is what? V equals CF, which is my focal length, all divided by A prime F, which is V minus F, right? So what am I going to do from here? I'm going to cross multiply. I believe at this point, everybody that is watching me will be able to complete this and arrive at the formula. But let me complete it. So if I were you, I'll pause the video and try to complete it from here and then play it and check if you're correct. So if I cross multiply, I have VF equals minus U into V minus F, right? So that VF becomes minus UV plus UF, right? Now, I'm going to divide all through this equation by UVF. So I'll do that. If I do that, I'll have VF divided by UVF equals minus UV divided by UVF, then plus UF divided by UVF. So if I do this, I would have that this would fizzle this, UV would fizzle this, UF would fizzle this. So on this side, what do I have? What am I left with? I'm left with 1 by U equal to, on this side, what am I left with? Remember, there's a negative here. So I'm left with negative 1 by F. Then on this side, I'm left with plus 1 by V. So I want to make 1 by F the subject, which is the standard we know. So I'm going to take 1 by F to this side. It becomes positive. I'll take 1 by U to meet the other one. So I would have 1 by F when it crosses being equal to, I have my 1 by V. Then when this crosses to meet 1 by V, it becomes negative 1 by U. So this formula here, you can see, this is what we know as our lens formula. So you can see that this is different from our mirror formula, following our sign convention. Our mirror formula is 1 by F equals 1 by V plus 1 by U. But our lens formula is 1 by F equals 1 by V minus 1 by U. So do not mix these two relations. If you have followed my video, you have followed this up till this point, and you really enjoyed what I've done, please do well to hit the subscribe button if you are not yet subscribed. If you're already subscribed, like the video, comment and share with 10 of your friends so that they can also benefit. Remember, this is Prime Concept. Thanks for always watching.